Hello everyone, welcome back to our channel. We are back again with a new video. In this video we are going to create a 3D concentric circles, a parametric circle using Python. So let us start this by importing the required libraries. So here NumPy is a library for numerical computation, especially for handling array and performing mathematical operations. So in this case it is used for generating a range of values t and creating arrays for x, y and z coordinates and performing mathematical operations like cos and sine. And matplotlib is a library which is used for creating visualizations in Python, and the pyplot module is a simple interface for creating various types of plots including 3D plots. Now we'll define parameters for the plot. So here numCircles, this specifies the number of concentric circles to the plot. In this case we have assigned to 10 circles, and radius step, this defines how much the radius of each successive circle increases. So the first circle has the radius 0.5, the second one has 1 and so on, which will add 0.5 to the next circle. And here Z step is that it controls how much the z coordinate height increases for each successive circle. So this step is 1, so each circle is placed at 1 unit higher than the previous one on the z axis. And tp is equals to np.linspace. Here it generates 100 evenly spaced values between 0 and 2 pi. So these values will be used to parameterize the circle in the xy plane using cosine and sine function. And now we will set up the plot. So this creates a figure with a specific size. And this creates a 3D axis for the plot. So here figure is equals to plt.figure. This initializes a figure for plotting a specified size of 6 inches by 6 inches, and ax is equals to figure.add. This adds a 3D subplot to the figure, and the argument 111 means there is only one subplot, and projection is equals to 3D. It ensures that the plot will be 3D. And now we'll loop to draw the concentric circles. So here a loop of radius of current circle that runs from I is equals to 0 to I is equals to numCircle 1. In this case 10 iteration for 10 circle, as we have taken the number of circles to 10, and R is equals to, here the radius of the current circle is calculated by multiplying I plus 1 by radius step. And here the z coordinate height of the current circle is calculated by multiplying I by z step. So this places each circle higher on the z axis by 1 unit. And here the x coordinate is calculated using parametric equation for a circle where r is the radius and t is the angle between 0 and 2 pi. So cos t gives the x position for each point on the circle. And here y is equals to, in this line the y coordinate is calculated using sin t for each value in t, and z is equals to np dot full. Like here the z coordinates for all points of the circle is the same, where z layer ensuring the circle lies flat at the constant height. So here this line actually plots the circle using the x, y and z values, and the label is used to identify the circle in the plot's legend. Now we'll set the titles and labels.